What's up guys, Patrick here, welcome back, and moving on to the next example, we got to figure out this limit. The limit as x approaches pi over 2 from the negative side of 3 cos x all over sine x minus 1. So with the limit, first thing you always check, can you do a direct substitution? And notice if we do a direct substitution here, let's actually quickly draw out the graph for cos x, because we're going to use it later in more detail. So notice this is cos x, this is pi over 2 over here. As we approach pi over 2 from the negative side, notice that cos x, this is going to be 0. So we're going to have 3 times 0, which is going to give us 0. And then sine x, if we draw that graph, as we approach pi over 2 from the negative side, notice that sine x is going to approach 1. So this would be 1 minus 1, which gives us 0. So unfortunately, we can't do a direct substitution. It's indeterminate form. But because it's in this format, 0 over 0, we can maybe apply L'Hopital's rule. So let's try that. So if we do that, what we would do is rewrite the limit, and then we would take the derivative of the top. Now the derivative of cos x is negative sine x, so we'd have negative 3 sine x, and then the derivative of sine x is cos x, and then the derivative of negative 1 is just 0. So from here, let's see what's going on. What we would have is we would have negative 3 times, as x approaches pi over 2 from the negative side, sine x is approaching 1. So we could plug in 1 here. Now, as x approaches pi over 2 from the negative side for cos x, we know it's approaching 0, but it's approaching 0 from the positive side, from here, right? Because notice all of cos x is positive as we approach pi over 2 from the negative side, right? All these values here are positive. So what's going to happen is this here is going to be a number close to 0, but it's going to be a very small positive number. So this is going to be a very small positive number. And so we're going to end up having negative 3, a constant, over a very small positive number, which would give us negative infinity. And so that is the answer to this limit. This limit approaches negative infinity. And this, approaching pi over 2 from the negative side, it actually made a big difference, because if it was approaching pi over 2 from the positive side, the numerator here would stay the same. But notice that this now, we'd be approaching pi over 2 from the positive side, so all of cos x would be negative there. Close to 0, but it'd be a very small negative number. And so we'd have negative 3 over a very small negative number. The negatives would cancel out, and we'd end up getting positive infinity, all right? So just be careful with these questions. Whether you're approaching these values from the positive or negative side can make a big difference in your answer.